In this video, we're doing properties of definite integrals and sort of just cleaning up everything into something called the fundamental theorem of calculus. So it's got a lot to do with area under the curve and sort of these properties which we've been using all topic anyway. But first thing we'll do is we'll just calculate this integral. So the integral from 0 to 3 of that is x squared, so that's the first term, and 2x from 0 to 3. So this becomes a 3 squared, take 2 lots of 3. So that was the 3 bit. And then we got to do the 0 bit, 0 squared, take 2 lots of 0. And if we work that out, that is 9 take 6, which is 3. So that was the integral there, it's 3. And interpret our results geometrically. So if I've got this graph of 2x take 2, what that will look like is sort of this thing here, a straight line up there. And when I integrate from 0 to 3, what I'm really doing is finding that area there, sort of. So there's 3, just in case you're wondering, that's 4. And this area has a certain value, and this area has a certain value as well. We can actually work out what those values are pretty easily. So I won't do too many more integrals by hand, but we can clear out these old ones in the calculator. We can go for 2x take 2 as our graph. Set our windows back up nicely. Probably the standard should do fine for this question. And then if we go shift G solve, go across to integral, and I'm just going to integrate normally from 0 to 3. You'll see that I get the same answer, it is 3. But if I go integrate from 0 to 1, I'm going to get minus 1. So that area there is -1. And then that area I'm going to presume is 4. So interpret your result geometrically. The signed area is 3. So -1 plus 4. That's basically what it is. The actual total area is 5 square units, because areas normally don't involve negative numbers. So that's a little difference between the negative stuff and the positive stuff with area. Now, this is where it really gets spicy. We're not going to give you a picture of this. I'm just going to give you those 3 integrals, and we'll see if we can use these properties above to figure out what that missing one is. So the integral from 1 to 6 is 5, and the integral from 4 to 6 is 2. We want to find the integral from 1 to 4. Well, the integral from 1 to 6 is like going from 1 to 4 and then going from 4 to 6. So if this was a function normally, and I wanted the area from 1 up to 6, I could get that whole yellow area there. Or if I want the area from 1 to 6, I could go and put 4 in the middle there. And I could get this green area and this pink area. And basically what I'm saying is that the green area plus the pink area must equal the yellow area. So you're splitting up into 2 pieces. And that's perfectly valid to do. So we can f of x dx, f of x dx, f of x dx. And we know 3 out of 4 of these things. So that thing the question gave us was 5. That thing we're not sure what it is yet, but the question also gave us that it is 2. So 5 is that integral that we want. So 5 equals something plus 2. I guess that thing must be 3. Now I really want to stress, this picture is a little bit misleading. Yes, that's what it would look like if the function is all positive, but it is very possible that your function, goes up and down a whole bunch of times between 1 and 6. So it's not always that clean drawing the picture like that. And you'll know that it's not clean if you get out negative numbers in your integral sometimes, or even if you have positive numbers, but if you integrate this function, it does go underneath for a bit, but the integral would still be positive, and then it could trick you. Okay, consider that function there. Find the swapped bounds, 3 to 1. When you swap the bounds, it is negative. That's all it does. That's a property of definite integrals. So you're going to get -7 there. That's all you got to do. Swap the bounds, makes it negative. Okay, now we got one with a picture, finally. There's a couple graphs. Region A has an area of 22, and A and B combined have an area of 56. So already I know what one of my missing areas is. That is 34. So A and B combined are 56. 22 plus 34 gives you 56. And we might say A is 22. Okay, find the integral from 0 to 2 of f. So this line here is f. So the integral from 0 to 2 should equal -a. Minus because it's underneath. So this is -22. No units on it because it's a definite integral, not an area. Find the integral from 0 to 2 of f take g. If this is on the top and the bottom, which let's check, yes it is. F is on the top, that's f there, and g is on the bottom, then that should just be the area of B, which is 34. Okay. It's known that that's true. Find the area of region C and the area of region D. So integral from 2 to 3 of f, what is that saying? So if we look at f here, and sorry, 2 to 3, not 0 to 2, integral from 2 to 3, what I'm saying is that all that area contained in there, that is the integral from 2 to 3 of f. Technically, yeah, well, the negative area is. So we could say that integral from 2 to 3 of f of x is negative of c plus d. That integral there they've given us. So negative 18 is the answer. So we can get rid of the negatives. 18 is just c plus d, like that. Okay. Next, integral from 2 to 3 of g is -13. So let's see what that looks like. If we got g, it's that straight line. So there to there, we're looking at that. That black area is the integral from 2 to 3 of g. Well, at least the negative version of that. So that tells us, what was that area? -c. Integral from 2 to 3 of g of x is -c. That's what we worked out with the picture above. So -13 is -c. So c must be 13. And now we know what d is as well. D is 5. Because we can sort of plug that c value back into there. 18 is c plus d, so d must be 5. Cool. Find the integral from 0 to 3 of that thing, f take g. So what we're after when we do that integral, if we do f take g, we're going to get b there and d there. So it gives us the area between f and g, which is b, and the area between f and g, which is d. I want you to pause the video and see if you can spot the error that I've made there. I've made something wrong on purpose. Hopefully you had to think about it. It should be -d, because f here is underneath and g is on top. If you got them the wrong way around, you get negative of that. So that should be b take d. Okay, you can map that out. B we worked out before was 34. And D was 5, so the answer is 29. Wonderful stuff.